Hi there, and welcome to our probability unit. You have a number of resources in Schoology. For example, deck of cards, deck of card chart, there's a dice chart, and there's really valuable notes with other examples. This is the kind of unit where we sort of learn by example because there's such a variety of ways that we see probability play out in life. So I'm going to give us a couple of examples, but I would really highly encourage you to take a look at the notes before trying the credits because you'll find a lot of parallels there. So I'm going to just kind of take us on this journey where we're beginning with probability. We're beginning with questions that have the keyword "and" in them. And so we're going to start down one branch called independent events. And so if you wanted to kind of keep track of this, this is also going to be up on Schoology, but we're going to sort of start in a place where we're talking about two different things happening. And the probability of one thing happening does not affect the other thing happening. So an example might be, what is the chance that it snows outside, and what is the chance that the Winnipeg Jets win? Well, the outdoor snow has no effect on the Jets winning. So these events are really independent of each other. Whereas if you were talking about the Winnipeg Blue Bombers, perhaps we're better at playing in the snow because we're from Winnipeg, right? And they've been training in the snow and they might have more of an advantage than, let's say, another team. So independent events, two events occur, but they do not influence the probability of the other event happening. So let's look at an example. The other tricky part about this with independent and dependent events is we're going to see the word "and." And for me, I'm going to want to use addition rather than use multiplication. So that's the first thing that's to sort of replace in your mind that when we see the word "and," we're thinking about multiply. And so we want to identify what are the two events that are happening. So right now we're talking about the probability of spinning blue. And here we have a spinner. You can imagine like there's a little I don't know, arrow kind of thing, and I'm going and it's spinning around, and you're going to land on one space, and all the spaces are evenly laid out. So there's 3 ways to get blue out of the 8 spaces total, or the 8 possible outcomes. When it comes to rolling a dice, and we're thinking about the probability of rolling an even number, the probability of rolling even on a dice is really the chance of getting a 2, a 4, or a 6 on the actual dice. So we know that there's 6 sides total, 6 things that could happen when I roll the dice, and 3 of them are even numbers. So if we use our formula, where we take the probability of the first event and multiply it by the probability of the second, that'll give us the chance that they both happen. So blue and even, we have to take the probability of the blue and multiply it by the probability of the even. So just a quick reminder for fractions in multiplying, you can actually just multiply across the top and across the bottom. You don't have to find common denominators. That's only for adding and subtracting. So here we'll have 9 over 48. And 9 out of 48 is one way of showing a probability. You can also convert this fraction into a decimal. So do top divided by bottom. Or numerator divided by denominator. And that'll give us 0.1875. It's really good to show all these decimals. Please don't round that to 0.2. Show as much as you can. And one other way to show probability is to show it as a percentage. So to take your decimal, if you times it by 100, or for some of you, you know that you're moving the decimal place 2 spots, we could say 18.75%. So, just shy of 20% of the time, I'll get a blue and an even number on the dice. So there's something a little bit tricky in probability, and that's where we're talking about the complement. So the complement is all the ways that something is not something else. So here I'm asking, what's the chance or the probability that I do not get a blue and an even on my spin and my roll? So for the complement, we're always going to take 1 or 100% of the things that could happen and subtract off the probability of that actually happening. So we know now the probability of getting blue and an even number is, I'm going to use the decimal because it's so much easier. 0.1875, and I just subtract that off of 1 to find my complement, which would be 81%. So 81% of the time, I do not get blue and even. Of course, you can also do this probability using the fractions. So had you used the 9 out of 48, you would get the complement being 39 out of 48. So 9 out of 48 times you get blue and even, 39 out of 48 times you do not get blue and even. Just want to look at one more example. And that's where they're giving us the probability. So, and oftentimes it's in the form of a fraction. We'll maybe create it ourselves. Here we have 2 scenarios. 1, I'm going out for lunch. 2, there's a chance of rain. And, we want to ask ourselves first, is this independent or dependent? Does one event influence the outcome of the other event? And no, my going out for lunch will not bring the rain, and the rain does not necessarily dictate me going for lunch. So I'm going to call this independent. And so I want to identify what are my 2 events that are happening. So first, what's the chance that I'm going to go for lunch? And percents are a little bit awkward to be using with probability, so I would rather show this as a decimal. So, even as like a little bit of a side calculation, divide by 100 or move that decimal point. So I've got a 35% chance of going for lunch. The probability that there's rain is 80% chance. So in terms of our questions here, go for lunch in the rain, that's asking what's the probability that I'm going to go for lunch and it is raining. So I'll take the probability of lunch and the probability of rain and multiply them together. And then the second example is asking, what's the probability that I will go for lunch and it is not raining? So we're thinking about that complement. So the probability of lunch and not rain. Notice that we're putting that line on top of the R. So lunch is the same. The probability of not raining, we might want to do that calculation off to the side. So Not rain will be 1 minus the probability of rain. So we're going to do that complement. So if there's an 80% chance of rain, there's a 20% chance that it's not raining.